Hello everyone. In this video, we are going to discuss about one previous year JEE question asked from the chapter Electrostatic Potential and Capacitance of class 12 physics. You see, this question is actually asked in the year of 2011. You will get all other questions from the playlist of this channel. So let us see the question. Two positive charges of magnitude Q are placed at the ends of a side 1 of a square of side 2a. That is, you see, we have a square of side 2a. That is, the length of one side of the square is 2a. Then there are two positive charges of magnitude Q are placed at the ends of one side of a square. So if you consider this side of the square, two positive charges are placed at the ends of this side. Okay, now two negative charges of the same magnitude are kept at the other corners. So you see, here I kept two negative charges minus q to the kept at the other corners. Okay, so at this corner minus q charge is here, and at this corner also there is one minus q charge. Okay, now starting from the rest, if a charge q moves from the middle of side 1 to the center of square, that is, this is side 1. Suppose there is a charge capital Q at rest. Okay, now this charge is moving from this point to the to the center of the square. So suppose this point is the center of the square. So this charge is moving from here to this point. So I am taking this point as capital letter R and I am taking this point as capital letter P. So this charge Q, it is moving from R to P. That is, from the middle point of side 1 to the center of the square. Now what is the question? When it is moving from the middle of side 1 to the center of the square, its kinetic energy at the center of the square is, three options are given. Actually there were four options. I just took three options, that's all. Okay, so we want to find out the kinetic energy of this charge capital Q at the center of the square, that is at this point P. You see, when this charge capital Q was here at the middle of the first side, you see it will have some potential energy. And when it is moving from this point R to the center point P of the square, its potential energy changes. That change in potential energy will get converted into its kinetic energy. So we want to find out the kinetic energy at the center, that is at P. To get that kinetic energy, what we want to find out? We just want to find out the change in potential energy. Okay, so you see, I am taking UR as the potential energy of this charge when it is at the point R, and I am taking UP as the potential energy of this charge when it is at the center of the square, that is at this point P. Now you see, we have the expression for the potential energy in general. U is equal to 1 by 4 pi epsilon 0 Q1 Q2 divided by R12, where R12 is the distance or separation between the two charges Q1 and Q2. Okay, so when we consider this UR, which is the potential energy at this point R, okay, we can write UR is equal to what? 1 by 4 pi epsilon 0. You see, when we consider the potential energy of this charge capital Q at this point Q, you see there is another charge Q here, there is one charge Q here, minus Q here and minus Q here. So we have to consider all this, the system of these charges. So we can write 1 by 4 pi epsilon 0. Then I am taking first this one. So Q into Q, okay, small letter Q into capital Q divided by the distance or separation between them. You see the totals, the whole side is of length 2a, so half will be a. Okay, so Q by a plus 1 by 4 pi epsilon 0. Now I am considering this charge Q, so Q into capital Q. Q into capital Q divided by the distance or separation between them, that is also a. So Q by a. Then plus 1 by 4 pi epsilon 0. Next I am considering this charge minus Q. Okay, so minus q into plus q, minus q into plus q divided by the distance of separation between these two charges. That is, we want to find out this distance. Now to get this distance, you see this is a right angled triangle. So this is the hypotenuse of this triangle. We know that hypotenuse square is equal to base square plus altitude square. That is, we can write a square plus 2a the whole square. So a square plus 2a the whole square, which is a square plus 2 square is 4, so 4a square. So this is equal to 5a square. That is hypotenuse square. That is the length of, square of length of this side is 5a square. So what about the length of this side? This will be square root of 5a square, which will be root 5a. Okay, so here this distance will be what? Root 5a plus 1 by 4 pi epsilon 0. Now we have to consider this charge and this charge. So we have to consider this distance of separation. Just like this, here also you can just calculate the length of this side. You will be getting it as square root of 5a itself. Okay, so you can write 1 by 4 pi epsilon 0 calculator q into minus q. So minus q into calculator q divided by the distance, the same distance you will get here. So root 5a. Okay. Now let us find out the potential energy of this charge when it is here at the center point P. So we can write the potential energy at P is equal to 1 by 4 pi epsilon 0. So suppose the charge is here at this point P. Okay. Now at this time, you see we have to consider the system of all these charges. The charges here at the point P. Okay. So in this case, first of all I am considering this charge Q. The charge capital Q now is here. So we have to consider this distance of separation between these two charges. Okay. So 1 by 4 pi epsilon 0 Q into Q divided by the distance of separation between them. What will be this distance? You see this is a right angle triangle. This distance is A. See, this is a center point. So this distance will be also A. So what about this side, this green side? That is actually the hypotenuse of this triangle. So we know that hypotenuse square is equal to base square plus altitude square, that is a square plus a square, which is equal to 2a square. So now next we are considering our charge q and this charge q, so that the potential energy between them can be written as 1 by 4 pi epsilon 0 q into q divided by the distance between them. Just like here also we will get the distance as root 2a. Okay, so root 2a plus 1 by 4 pi epsilon 0. Here we are considering this minus charge and this charge q. Okay, so this distance also be root 2a. Okay, so minus q into q divided by root 2a. Okay, plus 1 by 4 pi epsilon 0, we have to consider our charge plus q, and we have to consider this charge minus q. So minus q into q divided by the distance between minus q and plus q. This will also be root 2a. So root 2a. Okay, so potential energy at P, potential energy at P will be equal to what? You see this plus 1 by 4 pi epsilon 0 q by root 2a. Okay, this is minus 1 by 4 pi epsilon 0 q by root a. They cancel each other. 1 by 4 pi epsilon 0 q by root a and 1 by 4 pi epsilon 0 minus q by root 2a. They cancel each other. So potential energy at P, that will be equal to 0. Now, what about the change in potential energy? When the charge is moving from R to P, then change in potential energy will be what? UP minus UR. Potential energy at P minus potential energy at R. So, this will be equal to what? UP is 0. Okay, so 0 minus UR. UR is the potential energy at R. That will be what? This term. Okay, so I'm just writing it as UR itself. So UP is actually 0 here. So you see we have potential energy at R like this, 1 by 4 pi epsilon 0 QQ by A plus this term. We got the potential energy at P is equal to 0. So change in potential energy, which is the potential energy at P minus potential energy at R, which is equal to 0 minus UR, which is equal to minus UR. So this minus sign actually shows that the potential energy, actually there is a loss in potential energy. The potential energy decreases when it is moving from the point R to the point P. Okay, so this can be written as minus of, what is UR? See, 1 by 4 pi epsilon 0 QQ by A plus 1 by 4 pi epsilon 0 QQ by A. So this can be written as 1 by 4 pi epsilon 0 2 times 2, okay, 2 times the same term repeats. Okay, so 2QQ divided by A. Alright, similarly you see plus these two are the same terms. Okay, so we can write 2 times any one term. So 1 by 4 pi epsilon 0 minus 2QQ by root 5A. Okay, 2 times, okay, so 2 into this. Alright, now this can be written as minus of what? 1 by 4 pi epsilon 0. Then I am taking this 2QQ by A outside, so that it becomes what? 1 minus 1 by root 5. Okay, so this is actually like minus of, this minus sign actually shows that the potential energy decreases as it is moving from R to P. That is, there is a loss in potential energy. So that loss in potential energy is actually changes into the kinetic energy. So this term within the bracket, that is actually equal to the kinetic energy at the center of the square. So kinetic energy at the center of the square will be what? The term which is inside the bracket, which is 1 by 4 pi epsilon 0 2QQ by A into 1 minus 1 by root 5. Okay. So which one is the correct option? Option A is the correct option. You see, you will get all other previous year questions with solutions from the playlist of this channel. You can watch that if you want. Thank you.